You may have noticed that something a little funny happens involving units when we use radian angle measure. So let's have a closer look at that. So here I have an angle inside of a circle. This circle has radius 2 inches, and it cuts out an arc length that is pi over 2 inches long. How I know that? Well, you're just going to have to take my word for it. Let's use the definition of radian angle measure to figure out how big this angle is. So remember, the definition of radian angle measure is that the angle is the arc length divided by the radius. So our angle, size theta, this is a Greek letter theta, which is the traditional letter for angles. So theta, the angle, is the arc length, which is pi over 2 inches, and I'm going to be careful with my units this time, divided by the radius, which is 2 inches. So pi over 2, that's pi over 4. And if you look at the units, well, the units just simplify away. There aren't any units left. So this angle measure actually shouldn't have any units. No units at all. And that's how you know you're using radian angle measure, because there actually aren't any units at all. Now, it's a little bit strange, it feels a little strange to have a number floating around that represents a physical quantity, but for that number not to have any units associated with it. It just seems strange. It's not what we're used to. So as a note to ourselves that this number represents the measurement of an angle, we write radians. So a radian, the word radians, is just our note to ourselves that this number represents an angle measure. In actual fact, this number doesn't have any units associated with it. The upshot of this is when you're doing calculations with radians, sometimes the unit radians will appear or disappear depending on whether you're measuring an angle or not. Let's look at a quick example. So suppose we have a circle with radius 3 inches, and we put a right angle into it like this. The question I want to ask is, what is this arc length? Okay, well, since we know the angle and the radius, and we want an arc length, we should probably use our radian definition here, which is theta equals arc length over radius. We're going to want to know the arc length, so let's just multiply both sides by r here. And we get that the arc length is the angle theta times the radius. Okay. Now this angle, it's a right angle, and we know that right angles are pi over 2 radians. And the radius of this circle is 3 inches. So we get 3 pi over 2 times inches times radians. Now this seems bad at first because this arc length is a length. It should be measured in inches, but instead the units that we got are inches times radians. But remember, the radian unit is just a note to ourselves that we were measuring an angle. But we aren't measuring an angle anymore, so we should stop writing that note to ourselves. That radian unit really wasn't ever there to begin with, and so the unit we get for our arc length is inches, and that's what it should be. So you have to be a little careful with radians. Every once in a while, the unit radian disappears or appears out of nothing, depending on what you're measuring.